All right, log base 2, right? Because isn't when we look at 2 to the 3rd power, what's my base? Isn't 2 my base? So my base is going to be 2. Okay. Y or 8 equals what? 3. 3 to the 4th power, what's my base? 3. So it's log base 3 of 81 is 2. And then 5 squared equals 25. It's log base 5 of 25 is 2. Jeez. 2 is 4. I don't think my mind's working today. No. Yeah, I think so. Yeah, Monday night, I think. Oh my gosh. Okay, so your base is always the base of your exponential, right? Okay. And then your equals is always the exponent. Okay. Shoot, I don't know why. I'm sorry, guys. All right. Definition of log functions, okay? If x is greater than 0 and a is greater than 0, but a can't equal 1, y will equal, now something's not going to work. Y equals log base a of x if and only if x equals a to the y power, right? Isn't that what we all said? Okay. A is the base, right? The equals is your exponent, and then equals your x, okay? The function f of x equals log base a of x is the logarithmic function with the base a, which we talked about that, right? If we don't write a base, do you guys know what the base is? If I just say log of 100, do you guys know what my base is? It is 10, yep. So my base is 10 here. So log 100 would equal what? Ten to what power gets me to 100? 2, wouldn't it? Yep, 10 squared would get me to 100. Okay. All right, so evaluate each log at the given value of x. Okay, so f of x equals log base 2 of x. All right, so 32 is going to go in, so it's log base 2 of 32 is equal to what? So as we look at that, we're looking at 2 to what power would get me to what? 32. So what exponent of 2 would get me to 32? It'd be 5, right? 4 would get me to 16, and then 16 times 2 would be 32. Okay. All right. B, f of x equals log base 10 of x, and x is going to equal 1 over 100. Okay. So now in this case, we're looking at for log base 10 of 1 over 100 is equal to what? Okay. So we're looking for 10 to what power would be 1 over 100. Now, real quick, as we're looking at this, what kind of exponent makes a fraction? A negative exponent, right? So we're looking for a negative exponent. So we know my y is going to be negative. And then we look at 10 to what power actually gets to me to 100? 2. So y would actually be negative 2. Does that make sense to you guys? So anytime you see that fraction, we know it's going to be a negative exponent. Okay, and then look at 10 to what power gets me to that denominator. Okay. All right, use a calculator. So go ahead and pull out a calculator if you have one. Okay. Use a calculator to evaluate the function f of x equals log x at each value of x. So what's my base here? just 10, right? So we're looking at log of x. And what's my x in A? 10, right? In your calculator, type log 10. What do we get? 1, which should make sense because what's my base? 10. So 10 to what power would get me back to 10? 1, right? All right, now here, log of -2 equals what? So 10 to what power would get me to -2? Well, type it in your calculator. What's log of -2? It's error. Why is it error? Can we take in any number to any exponent and ever get a negative number? No. So can we take the log of -2? No. So there is no solution in this sense. We have an error, right? Because we cannot raise 10 to any power to get us to a negative number. Right? You guys okay with that? Okay. All right. So here are our properties. If I have log base A of 1 equals 0, why do we say that the log of base A of 1 equals 0? What's my base? A. We're raising it to what power? 0. Anything to the 0th power is 1. Does that make sense? Yeah. All right, log of base A of A is always going to equal 1. Why? Because A to the first power is always what? A itself, isn't it? It's always its identity. Log A of A to the x power is always going to equal x. Okay? Why? Okay, because A raised to the log A of x is always going to equal x. Okay. That's an A in there if you can't see that. Okay. So that's the new one that might make a little, that makes sense, I guess. Okay. If log A of x equals log A of y, then what can we conclude there? X equals y, yeah. Because if they have the same exact base, wouldn't these be the exact same values? Yeah, if we're keeping them equal to each other. Okay. All right, so go ahead and simplify. Log base 4 of 1, what does that equal? So this is asking 4 to what power equals 1? It is 0. So that would equal 0. What would log square root of 7 of square root of 7? What would that equal? So we're looking the square root of 7 raised to what power is equal to the square root of 7? It would be 1. Yeah. That makes sense to you guys? Now solve. Log base 3 of x equals log base 3 of 12. Do they have the same base? Yeah, and if they have the same base, x is going to equal what? 12. Right? Log base 4 of x squared minus 2 equals log base 4 of 10. So how would I set this up? X squared minus 2 would equal 10. And how do we solve for x squared? Add 2, so we get x squared equals 12. And then how do I get rid of the square? Square root. So x would equal plus or minus, simplify the square root of 12, 2 radical 3. Good. And how do we get 2 radical 3? 4 times 3, and what's the square root of 4? 2 radical 3. Any questions with this so far? Okay. And then last part is just graphing. Okay. So we're going to graph in the same coordinate plane, sketch the graph of f of x equals 2 to the x power and g of x equals log base 2 of x. What do we know about these? They're inverses of each other, aren't they? Right? They're inverse of each other. And if they're inverses of each other, whatever values we get for x and y, so whatever values I get for x and y here, what would its inverse coordinate be? It's flipped, so it'd be y comma x. So here's a question, which one's easier to graph first? What do you think? 2 to the x power or log of 2 base 2 of x? 2 to the x power. So let's pick some values for x. So we're going to do 2 to the x power. So give me some values for x. 0, 1, and 2. And how about negative 1 and negative 2? Is that okay? Is that okay? All right. So if I plug in, let's do 0. What's 2 to the 0th power? 1. What's 2 to the first power? 2. What's 2 squared? 4. All right. Negative 1. We have a negative exponent, so automatically it makes it a fraction. So this would be 1 over, what's 2 to the first power? 2. So it'd be 1/2. And then negative 2, we know it's going to be a fraction, so it's going to be 1 over, what's 2 squared? 4. Now, could we graph these points? Yeah. So let's go negative 2 to 1/4. I'm going to use these y values if you're okay, if I make those as going by 1s, not 2s there, so I can see a little bit better, if you guys okay with that. So negative 2 1/4, negative 1 1/2, 0 1, 1 2, and 2 4 1 2 3 4. So this would look like this. And again, we have a horizontal asymptote at what? Y equals 0, right? Because will I ever get negative values for y when we're raised to exponents? No. Okay. Now, for the log here, all right, so we're going to graph this one. We have our coordinates for 2 to the x power, my exponential. Do we have coordinates for my log? Yeah. So if I had negative 2 1/4, this would be 1/4 comma negative 2. And then if I have negative 1 1/2 for my exponential, it would be 1/2 comma negative 1. And if I have 0 1, this would be 1 0. And then 2 4 would be 4 comma 2. Now can we graph these? Yeah. So if we go over 1/4, down negative 2, so 1 2. I'm keeping them by 1s here. Okay. 1/2 negative 1, 1 0, and then 4 1 2 2. So it kind of looks like this. And there you go. So now what happened to my asymptote? Instead of being y equals 0, now it's x equals 0. Yep, x equals 0. Any questions with that? All right. Now, in example 6, it says, sketch the graph of f of x equals log x. Identify the vertical asymptote. Okay, so now we can do this two ways. One way is we could go ahead and find its exponential and then flip the coordinates if you want. Or could we just use our calculator and plug things in? Yeah, we could do that. All right. So which way do you guys want to do? Do you want to do the exponential, or would you rather do the quadratic or the logarithm using your calculator? Huh? Calculator? Okay. So, all right. So we're going to go x. So we're going to pick some values here. But remember, in this case, we're looking at our base. This is like 10 to the x power, right? Okay. That's the exponential. That's the exponential, not the actual. All right. So let's log 10. So we know our base is 10 in this case. Okay. Is everyone okay with that? All right. So log of x. So this would be my y, right? You guys okay with this so far? All right. If we want to look at x, x is what we're trying to find. Like 10 to what power, okay? 10 to what power would get me to x, right? Right. So give me some values, okay, for x, okay? Or give me, okay, how about this? Give me some y values that I can take the raise 10 to. Give me an exponent that I can raise 10 to. 2. Okay, so that's going to be my y value, wouldn't it? Mm-hmm. Okay. Give me another value I can plug 10 to. What other exponent can I bring 10 to? 1. I could do what else? 0. I could bring what else? Could I do -1? And could I do -2? Could I do that? Mm-hmm. Okay. If I look at 10 to the -2nd power, what is my x? So in this case, I'm not even using a calculator, actually. 10 to the -2nd power. Actually, you could use your calculator in that. What is 10 to the -2nd power? 1 over 100, right? So wouldn't log base 10 of 1 over 100 be -2? Yeah. What would be -1? 1 over 10? What would be 0? 1. What would be 1? 10. And what would be 100? Okay. Now, I worked backwards in this sense, didn't I? Now, we could have just plugged in random numbers for x, and you could have done -2, -1, 0, 1, and so on for x. And then could you type in your calculator log of -2? Log of -1? Yeah, you could. What happens when you do all of that, though? Don't you get tons of decimals, like crazy decimals? That's why I work kind of backwards in that sense. Okay. But does it matter if you really want to deal with all those decimals? Is that okay? Yeah. All right. I like graph. I'd rather graph this personally. Okay. All right. So can I go over to 100 up to? Yeah, we just know it's way over here, right? Way over that side. 10 to 1. Could we do that one? Over 10 up 1. Could we do over 1 up 0? Yeah. Could we do over 1/10 down -1? Yeah. And could I go over 1/100th and down -2? And could we get our shape here? No, that'd be all the way that way. Do we have a vertical asymptote? Yeah, of y equal, or excuse me, x equals 0. A vertical asymptote, right? Because will I ever get a y value that would be negative, or an x value that would be negative? Any questions with that? Okay. Now, describe the shifts. Do you think my shifts are going to change from quadratics? No, if it's inside the parenthesis, that always shifted it what? Left, right, right, left or right, and it was always its opposite. If it was outside, it shifted it up or down, and it was always the same. And then we do have reflections. That way, if we have a negative in the front, things like that. So if this was x minus 1, it's inside the parenthesis, so it's going to shift it which direction? Right? 1 unit. So could I take all those points that we just did down there and shift it right 1? Yeah. What do you think B? It would be up 2. Why? Because it's on the outside. It's not in that parenthesis. So could I take all those points and then shift it up 2 units? Yeah. If I had something like this, negative 2 plus log of x plus 4, what would this be? It would shift it down 2 and left 4. Okay. Does that make sense to you guys? Okay. Natural logs. Okay. The function of f of x equals log base e of x equals ln of x, or the natural log of x. X is greater than 0 is the natural log function. Okay. So the equations of y equals natural log of x and x equals e to the y power, those are equivalent. Okay. So ln gets rid of the e's, right? And the e's get rid of the ln's. Yeah, okay. So use your calculator to evaluate the function of f of x equals ln of x. You guys know how to use your calculators? Do you guys see where an ln is, the natural log? Yeah, okay. So if x is 2, could you find y when you type in ln of 2? And let's go ahead and round to 3 decimal places. So y would equal 0.693. ln of 0.0 or 0.3 is negative 1.204. ln of negative 1 without a calculator, what do you think? Error, right? It's an error. Why? Because when we take things to the exponent, right, will it ever be a negative number? No. All right. What about now? In this one, when you type it in, make sure you put 1 plus the square root of 2 inside the parentheses. Because if you take ln of 1, then plus radical 2, it's going to just take the ln of n and then add the square root of 2. All right. So make sure you put that in parentheses. And what would we get here? 0.881. Okay. All right. All right. Why do you think the ln of 1 is equal to 0? E, because e to the 0th power is equal to 1. Okay. ln of e equals 1 because e to the 1st power is equal to e. And then ln of e to the x is equal to x. And e to the ln of x is just x. So the e and the ln's get rid of each other, don't they? Okay. And then if ln equals ln of x equals ln of y, then x equals y. All right, use the properties of natural logs to simplify each expression. Okay. ln of 1 over e. Let me ask you, 1 over e, that is the same thing as e to what power? When e is a fraction, what is its exponent? Negative, right? So isn't that the same thing as ln of e to the negative first power? Is 1 over e the same thing as e to the negative first power? Yes, okay. And then what do we learn about ln? Where am I at? There you go, okay. ln of e equals 1, right? Is because e to the first power is e, right? So what do you think this is going to be? ln e to the negative 1. Or ln of e to the x is x. So the ln and the e do what? They cancel each other, and what would we be left with? Negative 1. I guess awake this morning? No, doesn't seem like it. Sam, are you awake? Kind of. All right, what about e to the ln of 5? What happens to the e and the ln's? They cancel each other, don't they? So what are we left with? Huh? 5. What's the ln of 1? 0. 0 over 3 is 0. What's the ln of e? 1, and 2 times 1 is 2. Because they cancel each other out, don't they? Any questions with that so far? All right. Now, for the domain, okay? The domain of natural logs is always x. Well, it starts with x is greater than or equal to 0. Okay? X is from the ln of x. So my domain would be x is greater than or equal to 0. Okay? Now, in this case, what happens here? My graph is shifting, right? You guys okay with that? It is shifting. So what you do is you're going to take x minus 2 is greater than or equal to 0. Why? Because this tells my graph I'm going to shift right, what? 2 units, correct? And so how do I move that 2 over? You add it, so wouldn't it be, my domain be x is greater than or equal to 2? Because if I start at 0 and I shift it right 2 units, wouldn't that be now at 2? Yeah, bless you. Okay. Now, in B, we have 2 minus x there. So this is the same thing as negative x plus 2, right? So which way is this one shifting? This one shifts to the left 2, right? Because it's plus 2. But what does the negative in front of the x do? Doesn't that tell me it's some kind of reflection? Yeah, when it's inside, it's a reflection over what axis? The y-axis, right? Okay. So when we set that greater than or equal to 0, what do you think is going to happen here? Because we're getting reflected, what's going to happen to that inequality sign? It's going to flip, right? Because when I subtract the 2 over, then what do I have to do? Divide by that negative 1, correct? So x would have to be less than or equal to what? 2. Okay, so that negative actually reflects it, which means my inequality sign is also going to be reflected, which is going to be changed. Okay. All right, now I put it as inequalities. Let's go back and put it as interval notation. X is greater than or equal to 2. What is that as in interval notation? 2, comma. What is x greater than or equal to 2? That means 2, 3, 4, 5, 6, 7, 8, all the way to what? Infinity. Now, with 2, do I include or exclude 2? Include, so that would be a bracket. Infinity is always a parenthesis, right? What would be x is less than or equal to 2? Negative infinity to 2. We have a parenthesis and a bracket. There we go. So interval notation. Any questions for that? Sorry, I was kind of like lost today. I don't know what. It's one of those days. I love when